Hi there. It appears as though the guided practice for guided practice number 6 on 4.1 rates of change did not include number 4. So I did want to go ahead and fill that in for you. Remember that we're using rates of change here. So we're finding the derivative using a limit definition. In this case, they're asking us for us to find it in general. So we're not going to use the f of a formula. We're going to use the f of x plus h. So that means we find the derivative, f prime of x, by finding the limit as h goes to 0 of f of x plus h minus f of x all over h. Now I'm going to go ahead and plug in. So my f of x here, this one, is exactly the function above, okay? But my f of x plus h means that in each of those x spots, here and here, I have to replace that with an x plus h that's in parentheses. It's going to look something like this. So we'll have the limit as h goes to 0 of 3 times x plus h quantity squared. So I take that x, replace it with an x plus h in parentheses, minus x plus h in parentheses plus 1. So that's my f of x minus f of x plus h. Then I want my minus f of x. Now I'm going to have minus, and then I'm going to put it all in parentheses because it's more than one thing. So that will give me the 3x squared minus x plus 1. All of that over h. Now, in order to move forward, if I were to plug in 0 right now and evaluate my limit, I would get 0 over 0. So I'm going to have to expand everything, cancel out anything I can, factor and cancel that h to see if I can get to something that is not 0 over 0. So that's what we're going to do. Now, be aware that when you have 3 times x plus h squared, that is 3 times x plus h quantity squared, because you square first, is x squared plus 2xh plus h squared. You can get that either by multiplying out x plus h times x plus h, or our rule of thumb when we square something, we square the first term, square the last term, multiply them, and double. So that's where the 2xh comes from. Then we're going to go ahead and distribute the 3. All right. That's going to give us the limit as h goes to 0 of 3x squared plus 6xh plus 3h squared. Now, I'm distributing this negative to the x and the h, minus x minus h plus 1. So that is all of my f of x plus h expanded. Now, I'm going to go ahead and distribute this negative, because I'm subtracting all 3 of those terms. So minus 3x squared plus x minus 1. All over h. Because now good things should happen. Anything that was in my function, so those 3 terms at the end, should have something to cancel with it. So this negative 3x squared cancels with this 3x squared over here. The plus x cancels with the minus x. The minus 1, ooh, I missed a 1 here, cancels with the positive 1. All of that should go away, so that the only things I should have left should have h's in them. So 6xh plus 3h squared minus h. Sorry, we're jumping around a little bit here. H, all over h. Now, I can go ahead and factor out that h in the numerator, because again, my objective here is to get rid of that h in the denominator so that I can plug my limit back in and not get 0 over 0. So this is h times 6x plus 3h minus 1 all over h. Then my h's cancel. And I'm left with the limit as h goes to 0 of 6x plus 3h minus 1. Now I've gotten rid of that h in the denominator, so I won't have 0 over 0, and I can plug in my 0. That means this term's going to go to 0 when I plug it in, and we're going to get 6x minus 1, and that, my friends, is my derivative. That is my f prime of x. And that's number 4.